Hello everybody, Adam Lusek here, and today we're going to be talking about deep agents, or language model-based agentic systems that are designed to solve long-horizon or long-running tasks. This style of AI engineering has been popularized by things like deep research, which we initially saw Google release in their Gemini interface and is now popularized across both ChatGPT, Claude, and other different AI applications, as well as some of the more agentic coding applications like Claude Code, Cursor Agent, and the others. With the main idea behind deep agents being creating these language model based systems that can essentially work on a problem much longer and much more thoroughly than the more shallow style setups. We refer to these kind of tasks as long horizon tasks, or essentially just any task that requires multiple steps over some longer period of time than just a minute or two. And this seems to be a natural evolution of how language model applications are being built, because as we explore and research more of the capabilities and usefulness of language models, we've immediately realized the value of them performing very small, initial, simple tasks. Things like quick web searches or, transformations of text, like converting something into a list or summarizing an article. But the actual value of those tasks to the end user tend to be a little bit limited. And so these deep agent systems aim to move past just simple task execution and enable language models to be able to work on much more complex, much more useful problems. And I would argue that this is a natural evolution if we look at how language models are being positioned as paralleling and mimicking how humans actually approach and do different digital tasks themselves. Research that compares language models' ability to complete tasks compared to a human's time to complete the same tasks has shown that early systems were decently successful in completing some of these simpler tasks, things like Wikipedia research or counting the occurrences of words in a passage. And as these language models evolve and become smarter and more capable, they're able to solve increasingly more complex or longer running tasks that take a lot more human time to complete. Things like algorithmic data deduplication or configuring Docker containers for proxies, and much more complicated or complex tasks that would generally take a human more steps and more time to actually complete the final deliverable. With the end goal generally being to exploit the intelligence of a language model to complete more increasingly difficult tasks in an automated way. And over time, as more research and people have developed these longer running agentic systems, a common scaffold and approach has emerged, which we are broadly referring to as deep agents or deep agentic systems here. But as it turns out, there's kind of four main characteristics of a deep agent. They tend to include a very detailed and specific system prompt, some form of a planning or to-do list tool, a file system for context management, and the use of sub-agents. So that's what we'll be going over in a little more detail today. All four of these specific components and how they actually all play together, and then in the end we'll combine it all to create our own competitive analysis deep agent that's going to be able to create detailed and accurate company profiles and compare them together for a full report. Along the way, we'll show a bunch of examples from some of the more popular deep agentic setups and use some open source packages to support our building. So let's start with the first component of the deep agent system, the system prompt. And the unique thing about system prompts is that we've seen with these agentic setups that the more long-running agents tend to have incredibly detailed and very articulate system prompts. If we take a quick scan of this snapshot of Claude Code system prompt, you can see that just in general, it's about 191 lines, and that's not even including all of the tool description and prompting here, which you'll notice this goes on for quite a few scrolls, and there are some even longer ones here for a couple of the different tools. And this all comes together to create a very, very outlined and detailed specific system prompt. So, very commonly, I'm seeing that a lot of these prompts are roughly 200 or so lines of code, not counting the tool instructions, and include a lot of specifics around things like tone, style, behavior, and tool use, all kind of blending together across those few hundred lines. We've always known that prompting is, of course, very important when it comes to guiding and aligning the behavior of a language model, but this truly reinforces that the more specific, detailed, and articulate you can be about what you want the language model to produce, the better results you can actually get at the end of the day. And there's some interesting techniques that are being used. We see a common use of what is referred to as few-shot prompting, or providing a lot of examples of how specific behavior or how specific tools should be used. Looking at Claude Code, they provide what I'm referring to as kind of pseudo examples that indicate how the behavior of the language model should happen. In this extracted example, you can see that the user asks for help on a new feature, and then it guides through that the assistant should create a to-do list. And then they're also including some things here like placeholders of future behavior. The use of these different placeholders referring to behavior are useful in these examples still, because one of the downfalls of very specific few-shot examples is that the language model will tend to mimic exactly what the examples are. So if you can keep these loose, refer to future behaviors, and kind of show what the desired interaction should be, that appears to provide a better end result. We also see the inclusion of things like styles and values. The Manus system prompt has things like values I uphold, transparency about capabilities, continuous improvement, accuracy and reliability, as well as communication styles. So it's not just technical agents, and it's not just pure specific execution examples, but also guiding through these different characteristics can help give the agent a little bit more of that personality that it needs to perform the task in an effective manner. But of course, these tend to be very personalized towards whatever the end result should be. Things like Cursor Agent has a whole code style guide saying that the code will be reviewed by humans, and then provides all sorts of things that the agent should follow when actually writing code, making sure it's high verbosity, using static type languages, avoiding to-do comments, and implementing, etc., etc. I've summed up some high-level best practices in these 4 points here. Essentially, that prompts can be long and complex as long as they are clear and organized. I would argue that a lot of these system prompts are much bigger than what we tend to see on one-off prompts or smaller systems that AI-forward developers actually tend to create. But the length of the prompt is actually not necessarily a detriment, as long as everything is very clear, organized, and provides some value to the interaction. In other words, I put that almost no space is wasted. There's also a bit of a clear hierarchy of introducing what the agent is and the overall functionality at the beginning of the prompt, setting the tone and the behavior, and then describing all of the functionality with clear examples. We also see still that XML tags, things like putting code styles in brackets or examples in brackets, is still used across prompting very heavily. Secondly, as I touched on just a few seconds ago, few-shot prompting and providing examples does help to reinforce the behavior, as well as understand how to use the tools that it has. And as mentioned, these are usually not super exact examples, rather general outlines of the behavior and some references towards future actions. I thought this was interesting because it's very similar to the kind of asterisk style of doing an action in there, which is a kind of common internet culture style of writing. But for this, the one recurring piece of advice is to not be super specific. Having the general outlines and referring to the different actions can help guide and generalize the behavior towards a multitude of different tasks. If you're too specific, it can backfire in a way that the model will more imitate exactly what you're trying to do in every scenario. This is used even more with the tooling. As I showed in the system prompt, it's not super readable in this one single line, But having heavily annotated tools that show multiple scenarios of when and why to use a tool is deeply included across almost every single one of these systems. They also show not just good examples of when to use a tool, but also show bad examples of when not to use a tool. So including both the good and the bad helps guide that even further. And finally, prompting is still semi-vibes based, I would argue. Important points are still reiterated multiple times at multiple different lines. We see multiple companies' preference towards first person versus third person prompting. Different perspectives are used in different tools. Some prompts are a lot more uniform, like Cursor's system prompt, and then others are a little bit looser, like Manus's system prompt. So there's still a decent amount of loose, kind of flowy organization that you need to kind of suss out while testing an agentic system here. We'll go over a prompt that I create for the competitive analysis deep agent here at the end, but I would encourage you to check out some of the linked prompts here that I have for Claude Code, Cursor, and Manus to get some ideas and some more specific examples of the full prompts and how they're set up. It's super unique and super worthwhile if you're prompting agentic systems day in and day out. So with the prompt out of the way, let's move on to the second of the 4 functionalities, the inclusion of a planning tool. One of the interesting, consistent things across all of these systems is that they tend to include and heavily use a planning or to-do list tool, where the model will go through some form of planning and update this planning frequently, breaking down the different steps that the model needs to take and the different actions that should be taken to approach or solve whatever request is sent its way. Now, doing this kind of planning step is nothing new. We've seen over the course of a couple of years now that including a planning step has greatly improved the accuracy and capability of language models, but this adds on to that with some specific context tricks. The biggest thing is that what was noticed is as the tasks increase in length and complexity, if a plan is made at the beginning, it tends to kind of get lost as the conversation evolves and more steps and more things are loaded into the context of the language model. So the way to address this is through encouraging the use of a to-do list tool. You can have the language model consistently refer to, refine, note what's in progress and what's actually been completed at multiple points along the entire lifecycle of the run. So this pushes the actual context and pushes the current objective and the different tasks to the front of the conversation. And through consistently referring to and observing and re-observing what needs to be done and what has been done, this tends to keep the model more in line with the actual objective and the plan. This is almost purely a trick to kind of exploit the attention mechanism because the actual tool itself, if you look a little bit closely, doesn't actually do anything. Most functions when they're called tend to, hit some API, take some action and return back some information. This literally just defines a to-do list tool and its only purpose is resurfacing and reiterating the actual plan to execute. I like to think of this from a more personal anecdotal angle. I am someone who needs to have a very detailed to-do list to stay on track, and I'm constantly referring to and adding notes to my to-do list and ticking off what I've done, and that helps me stay on track and know what I need to do next and know what's still in progress. So it's interesting to see that the same approach and style will help also a language model stay on topic and stay progressing on the task. So that is the planning tool. Now moving on to the third part, we have another context management trick here using a pseudo file system. Anyone who's worked with agents and agentic systems knows that as agents run and take more actions and produce more outputs or ingest more context, the amount of context that actually needs to be managed quickly balloons. And so language models tend to have decently large, what we call context windows, or the amount of tokens that we can shove into the language model before it maxes out. But as task complexity increases and the amount of context that you need to manage increases, it's very easy to move past the caps of these context windows. This is especially true for longer running deep agent systems, as if we look at things like coding agents, which might need to look across multiple files of code, or research agents, which need to look across multiple websites, the more websites that are loaded or the more files that are loaded, it quickly increases the amount of context that's being used. So it's not realistic to keep all of this context loaded directly into the context window. So to address this limitation, some inspiration from file systems has been used, and the ability to kind of write to files and open and close those different files to refer to the context within them as a way to both operate over and store what could be useful information to reference in the future. In short, the agent is usually provided with a way of creating, writing, editing, and then searching over different files. And so using these loads the relevant file information into the context, which can then be offloaded very easily when it's not needed, but a file path, URL, or unique identifier is still loaded where that context would be in the conversation history. This allows the language model to know what was being referenced for some sort of answer or some sort of action to be taken, and it can easily go back and reload the context of that file by just opening it. In the end, this uniquely provides a memory system that is compressible, restorable, and persistent across the run or the runs of a specific agent. Now, the fourth and final and likely most powerful part of all of this is the use of what we refer to as sub-agents. Now, sub-agents are essentially subroutines of agentic systems, nothing more than specialized individual tooling calling agents that can be invoked by the main deep agent. The way this works is that the main deep agent system knows that it has some form of sub-agents available and will dynamically spawn and delegate individual specialized tasks to each one of these sub-agents. This tends to be done with the form of a function call, where the deep agent will call a function, specify which sub-agent it wants to use, which has been defined by the developer or the system, as well as generate some specific instructions for that sub-agent. The sub-agent will then go off, perform whatever task is needed, and then provide a full answer back towards the deep agent system. This is a little bit different from some of the more popular multi-agent setups like supervisor systems that orchestrate a lot of predefined agents and how they communicate together, because these are more subroutines and kicked off dynamically, and one or multiple sub-agents of multiple different varieties are essentially created on the fly to perform specific tasks. This is different from relying on a predefined system and some form of routing logic via a language model. But what are the benefits of sub-agents? Essentially, they provide context management, modularity, specialization, and efficiency benefits. Once again, we rely on some context management tricks here with sub-agents, as each sub-agent operates within its own defined context window. So it's not polluted by any of the overall system prompting, and is allowed to focus on just the specific task at hand along with the tools that it has. So this lets it pass only the most important context back to the deep agent system and its final answer, without requiring every single granular action that's being taken and all of the context that's been referred to pollute the main system. In other words, it runs completely isolated to solve the task and then provide the information back. And this approach is purely a kind of agent as a tool style, where you'll kick it off and then get a final return. You won't get the intermediary steps or add any of that back towards the main run of the deep agent. So with this, that provides a lot of modularity and specialization. We can define task-specific sub-agents to really boost performance of specific tasks that need to be done over the system. and include things like more narrow prompting and custom built tools for the job to more directly tackle specific pieces of what you're trying to accomplish. And on top of all of this, a common approach is to be able to invoke subagents in parallel so multiple can concurrently progress on multiple outstanding tasks, giving us some massive efficiency boosts. As a little bit of history, Anthropic have been the ones really researching and doubling down with subagents directly integrated into things like Claude Code. And over a year ago, they initially showcased in Claude 3 Opus as an economic analyst the early introductions of subagent systems performing multiple tasks like this. So all four of these different techniques, a detailed system prompt, a common to-do list, a file system for context management, and the ability to use and spawn subagents all come together to encourage our deep agent system to perform much more long horizon tasks. So with that, let's actually build one. So with the theory out of the way, let's put all this together and use some packages to build and run a deep agent. Now, my idea for this, as mentioned a couple times, is a competitive analysis deep agent. With the introduction of things like deep research, I've always been interested in how we can further exploit or further customize the ability to search the web and do these specific web research style tasks into a more specific vertical. So that is where the idea for taking a deep research agent and putting it into a competitive analysis scenario came about. So at a high level, I hope to make a deep agent that can perform these competitive analyses. So it will need to dig further into things like company research, provide key comparisons, use web search tools to browse and find relevant information from across the web, and then compile those into some form of a report. To do this, we'll be using one of the new packages coming out of the LangChain crew, the Deep Agents package. And this is an incredible package, so go ahead, check it out, give them some love, give them a star, and look at the source code, because those, much smarter than I, have set up these incredible frameworks in a nice open source manner. And not only have they provided a phenomenal package here, they've also provided some examples, one being a general web research agent. So much of what I'm going to go over has been inspired by and reuses some of the code from LangChain. But with that, you can very easily install deep agents using your favorite package manager like UV or pip here. And on top of that, we are also going to be using Tavily for our web search client. Now, to start, what we are going to do is define, of course, our system prompt and apply what we learned to create a well-organized and thorough competitive analysis prompt. Now, this prompt is about 430 lines long, so I'm not going to go over every single one. Of course, all of this code is linked and open for use in the description below, but I'll go over some of the main points here and show where I applied some of those different techniques into the prompt. Of course, we start with defining the scenario and what the primary function of the system is, and then go immediately into identity and behavior, showing what we excel at and the different workflow that we have. And then we define more specifically some of the subtasks that are going to be needed to do some competitive analysis, and using things like XML tags to clearly outline where we are defining these. So we have things like the research approach, where we show how the company profile and competitive intelligence gathering should be made, and then also how the different deliverables are actually going to be formatted. So we have two separate files, one that will contain company profiles, as well as then finally at the end here, a competitive analysis right around here with file 2, and some very much specifics around everything that's going to be expected for each one of these sections of the deliverable. On top of this, we have a quality checklist just to make sure that we are up to our standards that we're expecting. And then finally, we go into good and poor examples of using tools, which in this case will be kicking off the different research agents and the critique agent, which we will define here in a second, showing some good examples and some poor examples and how to actually prompt those nicely. We continue and reiterate some of the reminders that we defined up at the top, with things to always do, things to never do, some general language requirements of just following whatever the user's original request is, and how to handle different challenges like missing information or conflicting or limited information that you may run into across all of your research here. So you can see, very defined, pretty organized, and very specific system prompt that has a lot of the different characteristics of what we've seen in the past. So with this, we also have to write a couple more prompts for our sub agents. As referred to in here with the critique and research agent, we're going to have two forms of sub agents. One, of course, is going to be the more research style that's going to have most of the web search capabilities that the deep agent can kick off to do the more specific granular research tasks. And then we're also including a critique agent that can review and suggest improvements of the reports towards the end. So for the research subagent prompt, this one's a little bit more similar to, I would say, Manus's system prompt, where we talk about core capabilities and research approaches, outline specific structure and information depth, as well as quality standards, and show some examples, but don't get super duper specific into exact formatting or exactly how things should be organized. We do just give some specifics of how to act and what to look for some of the specific things we're looking for, like company trajectory or features and capabilities. Some of the big things that we reiterate is that the response must be complete and self-contained, as just the final output is going to be returned back to the deep agent. And also one thing to note is that the agent itself is going to also prompt this with specific instructions. So this prompt is going to be attached alongside those instructions to perform the sub research. Alongside this, we also have the critique subagent prompt here that goes over just how it should critique the competitive intelligence reports. It's pretty similar to the sub research one, where we just show how it should do this, where these files are actually located so that it can look and see at the different context here, and some formatting, but I don't have it be super specific in this so that it can have a higher level critique. But as you're probably starting to realize, the bulk of the work of setting up these deep agent systems is really clearly defining your prompts, which is an exercise in kind of defining your requirements and expected outcomes for the project and for the agent that you have here. So it's really good, and a lot of pre-work should be put into clearly defining this stuff and clearly outlining exact behavior and exact functionality within your deep agent, as that will only ever correlate to improved performance. On top of that, we just put together a quick web search tool in the form of a function, and then we'll use the deep agents package to package up our subagents with a name, a description, a prompt, and tools, and then put them all together with our main prompt and tool to create our deep agent here. These descriptions here are also going to be what's passed towards the deep agent, the main agent, so that it knows what the specific subagents can do. So it's also good to put in some specifics here. Of course, we are going to package this all up nicely, not run it here in a Jupyter notebook. So I have all of this in the same directory and repository that this notebook is in, under the competitive analysis agent folder here, which shows how to put everything together into one file and configure everything for the LangGraph platform. It's essentially all of the code that we just saw, just all put together here. And then the only different thing that I have is towards the end, I am defining a specific model. So we'll be using GPT-5 as our model here. And then you package this all nicely with the LangGraph JSON config and path over to your competitive analysis agent. I have, of course, also in the code a full recommended setup if you wish to set this agent and run it up yourself. What I do recommend is also using one of LangChain's additional packages, the Deep Agents UI, which provides a nice front end for interacting with whatever deep agent you actually define. I'll have that linked in the description below, but once you have everything set up, you can essentially run the server for the front end, as well as run the LangGraph server at the same time. And what this will do is it will open up LangGraph platform and compile your agent, which in our case is the competitive analysis agent. And then if we go to localhost 3000 here, we shall see here we go, Deep Agents UI. And just to reiterate, I have everything linked below of how to set this up in the competitive analysis agent folder here of the main repository. But the query that we are going to try out is create a comprehensive competitive analysis comparing Linear and Asana as project management solutions for product development teams. And we can send this off to our deep agent and we'll see that it will start working. And after a little bit here, we should start to see some of the to-dos pop up, as well as some of the sub-agents start to run. Just like this. So I'll let this go and spin for a little bit, and we shall check out what happens at the end. So I've gone ahead and ran this prior and let it spin. And in the end, looking at the full trace and Langsmith in the back here, we can see that it ran for a whopping 2075.6 seconds, or just under 35 full minutes. And has output a full company profiles file here for both Linear and Asana, as well as this total competitive analysis with some of the links. Digging briefly into this trace, we can see that it initially wrote a bunch of to-dos and then started writing things down, like our analysis request to the file, updating the to-dos to currently in progress, and then it sent out, actually if we look in the waterfall, it sent out multiple of these different tasks in parallel. So these tasks are where it was sending out the sub-agents to do specific research. So we can look at something like this one, where the main system kicked it off for deep dive research on Linear's company profile, mission and positioning, and return back the dates, locations, and headcount estimates with source. And you can see that it kicked off a whole bunch of internet searches here. And so you can see how useful these sub-agents are, as multiple, about 10, were called in parallel from the main system with the specific decomposed to-dos. So this one, the next one that I called, was for Linear product features, tech stack, and integrations, and it goes on and on. So these specific sub-agents will run in parallel, and you can see some of them take 4 minutes, others take around closer to 5 minutes, and they all go, some of them even getting up there towards almost 10 minutes running. And these are individual sub-agents, so they do have some sort of reflection in where they'll look at what tools they're using, look and see if they've actually been able to answer the full question and ask, and still continue and not stop until it has the perfect information. Which in the case of our model who was looking at the company profile, we can see that the output here gives a whole bunch of links as well as all of this specific information, which is some really good stuff here. And this all goes on for a while, and the main system will wait to receive that information back from the different sub-agents, kicking off more sub-agents if needed, or coming back and starting to produce some of the final deliverables that we asked for. So in this case, it finally does get to write the file where it will write the competitive analyses as well as the company profiles. All the while, it is updating its to-do list and making sure that everything that has been done has been marked as completed or in progress until it eventually hits the point where it calls another sub agent, the critique agent, to actually go through and edit all of the files, which it'll look at what files are available, read, and provide some information. And then there's a little bit of back and forth where it calls the critique agent again, does some one-off internet searches to find some of the missing information, all the way then 36 minutes later, where it finally decides that everything has been completed and we have delivered the deliverables. And we can see that the quality of output is actually really good. So our company profiles here are very detailed. We have some super good overviews of Linear positioning their target market, their different products, pricing and packaging, technology and integrations, notable customers, different funding, strengths, weaknesses, customer sentiment, common complaints, review scores from trusted sources, and the same for Asana. All of that there. And then this all goes together to create our final competitive analysis that we're looking for. That includes our executive summary, a at-a-glance company comparison, their different positioning, comparison and breakdown by features, and target market, pricing, a whole SWOT analysis that goes over the strengths, weaknesses, opportunities, and threats for both companies, some of the competitive dynamics, recommendations, conclusion, and even sources down there at the end. So even though it ran for a whopping 35 minutes, the output and the usefulness and specificity of the output that we were able to get, I would argue, is totally worth it. I could not put together something as incredibly detailed and specific as this in the same amount of time. So it really shows how these deep agentic systems are shifting the paradigm from more of these shallow one-off task execution chatbots towards creating language model-based systems that can really provide a whole lot of value and tackle a lot more complex long-running tasks. To break down some of the summary statistics that we have here, across the 35 minutes that the agent ran for, we processed almost 7 million tokens across 198 language model calls, totaling about 6.9 million input tokens and 22,000 output tokens. It spawned 12 specific subagents, 10 for the research and 2 to critique. Across that, 287 web searches were made during the course of the 35 minutes there, which comes out to about an average of 1 web search every 7.2 seconds. So the amount of speed that these things can actually operate at is superhuman. Now, these benefits certainly do come at a price. The total cost for just one single 35-minute run came out to almost $9 for me here in the end. Now, albeit I was relying on the full GPT-5 for everything. Some optimizations can be made here of using smaller models for the sub-agents and just relying on a larger model for the orchestration of it, but I wanted to see what quality I could get if the cost wasn't necessarily a prohibitor using the latest and greatest from OpenAI as of the time of recording, which this does math out to about $15.27 an hour. So there's much to be considered about the economics of these things and the productivity gains of these, but I'll leave that for a further exploration and further research and for you to think about at home. But with that, we've managed to set up and show exactly how deep agents operate, as well as make one of our own and successfully run it for a more complex long-running task. I will, of course, have the link to all of the resources, as well as additional readings, blog posts, and everything that I used from the LangChain repository linked in the description below. And once again, I implore you to go check out some of LangChain's other resources that they have, as they were incredibly useful at the time of putting together this resource. So big shout out to them. But in the end here, I hope you learned something, have some interesting code that you can go away with, and are starting to think of some of the different areas and use cases that you could apply deep agents to yourself. So if you like the video, like the video. If you have any questions or comments, leave them in the comments below. And if you want to see more, consider subscribing. Thank you and have a great day.